In this video, we're just really quickly looking at some notation and examples for second derivatives. So what does a second derivative mean? It means that you differentiate a function twice. That's it. So we could have in prime notation, you apply the derivative once and get f prime of x. You apply the derivative again and you get f double prime of x. And that's our notation for the second derivative. And I see that in the second example below. Alternatively, we could use the Leibniz notation and say the first derivative is df dx. Get the derivative of that, and the notation for it is like this: d squared f dx squared. And the reason it's written that way is because sometimes it's useful to split off the second derivative operator and say, oh, that's the thing that gives me the second derivative of whatever I apply it to. So I can split the f off and look at the second derivative as an operator instead of looking at it all together. And I noticed this notation in the first example. So my first example says, give me the second derivative of the square root of x. That's d squared dx squared of this thing, the second derivative operator applied to square root of x. And so you might not have to write this down, but I'm going to make it really explicit. The way to differentiate the square root function is to view it as a power. I apply one derivative, leaving me with only one derivative. All right, so the second derivative of x to the 1/2 is the same as the first derivative of the derivative of x to the 1/2. I'll go ahead and apply that derivative before I clean things up. And again, I'm just using the power rule. So bring down the power of x, and I get negative 1/4 x. And then subtract 1 from the original exponent. And negative 1/2 minus another 1 is negative 3/2. So I can clean this up as negative 1 over 4x to the 3/2. In our second example, I have the tangent function, and I want the second derivative. I just wrote it in prime notation this time. And my first derivative is secant squared x. It's a formula you should just memorize. My second derivative is going to require the chain rule. So I have the secant function raised to the second power. And maybe it'd be good to highlight that by writing it this way: secant x to the second. When I differentiate this, I just differentiate the whole thing with respect to the interior. So I treat the interior like a single variable. And when you differentiate something squared, you get 2 times that something. Then the chain rule says you better tack on the derivative of that interior function. And that's secant x tangent x. So I end up with 2 secant squared x tangent x, and we're done. If you find the math content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce dozens of new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.